Hi guys, tonight we're going to take a look at another way to solve a systems of equations. We have done graphing, we have done substitution, and tonight we're going to take a look at using elimination. And elimination means to get rid of something. So in this case, what are we going to get rid of? We're either going to get rid of x or we're going to get rid of y. And if we get rid of one variable, then we can go ahead and solve for the other. So sometimes neither equation can be easily solved for one variable, but you're still able to solve the system. So we're going to take a look at the elimination method. And the elimination method is we're just going to add or subtract equations to eliminate one variable. So we're either going to eliminate x or y. Notice it says or. We're not going to eliminate x and y. We're going to eliminate x or y. So there's four types of elimination methods, and type 1 is the easiest. So we're going to take a look at this example right here. So this is where we can add the equations to eliminate. So if I look at my coefficients of x, if I add -4 and 4, I'm going to get 0x. And I look at my coefficients of y, if I add those two, I'll get 6, and if I add -12 and -24, I'll get -36. So that's what we're going to do. We're going to add these two equations so that we can eliminate, in this case, we're going to end up eliminating x. So if I add -4 and +4, that gives me 0x. -2y plus 8y is 6y, and -12 and -24 are 36. So what I'm left with is 6y equals -36. And since I've gotten rid of this x variable, now I have an equation with one variable, and I can go ahead and solve for y. So I'm going to divide by 6, and so my y coordinate is -6. So when I'm writing my solution to this system of equations, I know that my y coordinate is 6. So now we have to find the other variable. So we have to find x, and we know that y is equal to 6. So I can pick either equation. I can use this equation up here. I can use 4x minus 2y equals -12, or I can use 4x plus 8y equals -24. And I'm going to go ahead and use the first one, 4x minus 2y. So it's -4x. So -4x minus 2y equals -12. I'm going to take out y, and I'm going to plug in 6. So I get -4x minus 2 times 6 equals -12. And then I'm going to go ahead and solve for y. And again, this should be a -6. Sorry, that's a -6. And that's a -6. That gives me a +12. And then I get -4x by subtracting 12 gives me -24. Divide by -4, divided by -4, and I get x equals 6. So there's my solution to this system of equations. If I substitute 6 in for x and -6 in for y, it's going to work in both equations. And if I were to graph this, this would be the point of intersection on the graph, if we were to graph these two. Okay, so what happens if you look at this and you say, well, I can't add to eliminate? That's always going to be your first step, to check to see if you can add to eliminate. If you can't add to eliminate, then we have to see if we can subtract to eliminate. So if I try to add these two coefficients, negative 7 and 1, because that's really what's right here is a 1, I can't eliminate by adding. And if I add a negative 2 and a negative 2, I end up with a negative 4. So in this case, we want to subtract to eliminate. So we're going to subtract that second equation, the entire thing. And I'm just going to rewrite that over here, 'cause it's a little easier to see. So we have negative 7x minus 2y equals negative 13, and we are subtracting the second equation, which is 1x minus 2y equals 11. So how do I know if I say subtract? Well, I'm looking at the coefficients of y, and they're the same. So what happens if I do negative 2y minus negative 2y? So that's what we're going to do. We're going to subtract the entire equation. So I'm doing negative 7x minus 1x, and that's going to give me negative 8x. Then I'm going to do negative 2y minus negative 2y, and that's the same thing as negative 2y plus 2y, so that's going to give me 0y. And then negative 13 minus 11 is going to give me a negative 24. So when I simplify everything, I get negative 8x equals negative 24. Divide by negative 8, and we get x equals 3. So for our solution, we have our x value, and our x value is 3. Now we have to use that x to go back and find our y value. So we are going to find y, because x is equal to 3. So I'm going to use the bottom equation because it's got less coefficients. So x minus 2y equals 11. I'm taking out x, and I'm plugging in 3, so I'll move it over here. I get 3 minus 2y equals 11. Subtract 3 from each side, and I get 2y, negative 2y equals 8. Divide by negative 2, and I get y equals negative 4. So there's my solution to this systems of equations. If I plug in 3 for x and negative 4 for y, in both of these equations, it will work, and this is the point of intersection on the graph. So what we've done is we looked at two ways. First, we check to see if we can add. If we can, then do it. If we can't, then we have to check to see if we can subtract. We're looking for coefficients that are the same. And if neither of those methods work, then we have to multiply one equation. So let's go back here. So my coefficients of x are negative 5 and 3. And to get a common, the least common multiple of negative 5 and 3, we'd have to multiply this times 3 and then this times negative 5. So if I look at the y variables, this one has a coefficient of negative 8, and this one has a coefficient of 1. So how can I make this an 8? Well, I can multiply that times 8. So that means I want to multiply the entire equation by 8. I can't just pick this one. So we're going to take this equation over here, and we're going to multiply it by 8. So we're going to do 8 times negative 5x plus y equals negative 3. And when we do that, we end up getting negative 40x, because we're multiplying that time 8 times negative 5. We end up getting 8y, because that's 8 times y. And then we end up getting negative 24, because that's 8 times negative 3. So now if we take this equation and write it under here, which is 3x minus 8y equals 24. Now if we look at the coefficients of y, we can go back up to step 1 and step 2, or part 1 and part 2, and if I add these two equations, this will get eliminated. So that's what we're going to do. We're going to add these two together. Negative 40x and 3x equals negative 37x. These guys are going to cancel out. And 24 plus 24 equals 0. If I divide by negative 37, we end up getting x equals 0. So that's part of our solution. Our solution so far is x equals 0, and now we have to find y. And when we find y, we want to use one of the original equations. And I'm going to use this one right here, because once I substitute x in there, I can figure out what y is simply. So now we have to find y when x is equal to 0. So my equation is negative 5x plus y equals negative 3. Negative 5 times 0 plus y equals negative 3. Then I get y equals negative 3. So there is my solution to that system. So this is where we multiplied one equation to get a coefficient that matched. Now the last one, type 4, is to multiply both equations. So we want to look and see which one would be the easiest to multiply. So if we look at 7 and 2, I want to find the LCM of 7 and 2. So the least common multiple of 7 and 2 is 14. So how can I change this to 14? And how can I change this to 14? Well, I can multiply that times 7, and I can multiply that times 2. So that's what we're going to do. The first equation, we're going to multiply times 7, and the second equation, we're going to multiply times 2. And when we do that, we distribute everything. We get negative 14 plus 42y equals 42, because keep in mind that 7 gets distributed on everything. And the same thing with the 2. 2 times negative 7x is negative 14. 2 times 8 is 16, so that's 16y. And 2 times negative 5 is negative 10. So then we go back up and say, okay, well, can I add these two to eliminate? They're the same, but I can't, so what I can do is subtract these to eliminate. So I'm going to subtract everything inside these parentheses. So if we do 14, negative 14 minus negative 14, that's going to give us 0x. 42 minus 16 is going to give us 26y. And 42 minus a negative 10 is going to give us 52. So now we ended up with 26y equals 52. Divide by 26, and we get y equals 2. So that's the first part to our solution to this system. We get a solution, whoops, not x equals 2, but y equals 2. So now we have to find x when y equals 2. So we need to pick an original equation. So we want to pick one of these two. We don't want to pick this. So I'm going to pick negative 2x plus 6y equals 6. So negative 2x plus 6y equals 6. I'm going to take out y and plug in 2. Hopefully. And then I'm going to solve for x. So I get negative 2x plus 12 equals 6, and then I get negative 2x equals negative 6, divide by negative 2, and I get x equals a positive 3. So there's my solution. My solution is 3, 2. Alright, so now it's your turn. What would the first step be in solving this system of equations using elimination? So again, you have to look at the coefficients of x and the coefficients of y. Can you add them? Can you subtract them? If you can't do either of those, what can you do to either the coefficient of x or the coefficients of y so that these two can easily be added or subtracted? The second one, you're going to solve the system of equation using elimination. So again, check to see can you add or subtract any of these. And I believe this one right here is supposed to be a y. So it should say 6x minus 5y equals negative 9. So look at the coefficients of x. Can you add those together to eliminate them? If you can, then do it. Then look at the coefficients of y. Can you add those together to eliminate it? Be sure to enter your answers on the Google form.